So who knows what a function is, right? But I know what it does. It takes an input value and produces an output value. And we've got a whole bunch of functions, right? And we can take these functions and start asking questions about them. What happens when you plug in a really big number or a really small number? Or what happens when you plug in two numbers that are nearby each other? How are the outputs related, right? Those are the kinds of questions that are going to occupy us for the rest of the term. But even before we start thinking about questions like that, right, there's some things that we can still ask about functions. Like, how do you know when two functions are the same function? For instance, here's two functions. F of x equals 1 plus x quantity squared. G of x equals x squared plus 2x plus 1. Are these the same function? Well, let's try. Let's look at a value like f of 2. F of 2 is 1 plus 2 squared, just replacing the x by 2. 1 plus 2 is 3. So 3 squared is 9. Well, what's g of 2? Well, g of 2 would be 2 squared plus 2 times 2 plus 1. 2 squared is 4. 2 times 2 is 4 plus 1. 4 plus 4 is 8 plus 1 is 9. Look, f and g, when I plug in x equals 2, give me the same output value of 9. And that should be a little bit surprising, right? Because the way that f and g are telling me to compute their output is totally different. F takes the input 2, adds 1 to it, and squares it to get 9. G takes 2, squares it, doubles it, adds those two numbers to 1 to get 9. So the method by which f and g are doing the calculations is totally different, right? This sequence of operations is not the same as this sequence of operations. The rules are different. And yet, look at this. F of x, for any value of x, right, is 1 plus x times 1 plus x. Right? That's 1 plus x squared. Well, I could expand this out, right? 1 times 1 plus x, and then x times 1 plus x. And I could combine some of these terms, right? 1 plus x is 2x. X times x is x squared. Look, 1 plus 2x plus x squared, that's g of x. This is really quite surprising. F and g don't compute their output in the same way, right? This one is doing something different than this function. And yet, for any input value, f's output value is this, which is the same by expanding out as g of x. So how are we going to deal with this? We're going to say that f and g are the same function, right? Not because they have the same rule, right? But because for every input value, they have the same output value. Here's a much more subtle example. Again, I've got two functions. F is defined like this. F of x is x squared over x, and g is defined like this. G of x is just x, the identity function. Same question. Is f the same as g? Are these the same function? Now, they're not the same rule, right? This is not the same as this. So, it's a little bit more subtle, But that's okay, right? Two functions are the same if they have the same output for each input. So let's see if that happens here. Let's just pick some value to get a first test. Let's take a look at f of 5, right? F of 5 would be 5 squared over 5. That's 25, 5 squared divided by 5. That's 5. Well, that's the same as g of 5, right? If I plug anything into g, I just get the same thing out. So plug in 5, get out 5. So at least at the value 5, f and g agree. You might think this always works, right? Because of something like this. You might want to say, well, f of x, that's x squared over x, no matter what x is. You might rewrite this x squared as x times x over x, and then you'd be tempted to say cancel one of these x's with the x in the denominator, and then you'd write equals x. And x, well, that's g of x. So this looks like a pretty convincing argument, right? Over here I've got f of x, I've got a bunch of equal signs, and over here I've got g of x. So maybe that means that f and g are the same function. But not so fast. What happens if you plug in 0? What's f of 0? Well, I know what g of 0 is. G of 0 is 0, right? 0 is in the domain of g because 0 makes sense for this rule. But what's f of 0? Well, that would be 0 squared over 0. Whoa, okay. You see, this is terrible, right? I cannot divide by 0. This rule, x squared over x, doesn't make sense when x is equal to 0. So 0 is not in the domain of f, but it is in the domain of g. So I'm going to say that these are not the same function. They don't have the same domain, right? F isn't defined at 0, and g is defined at 0. In that sense, these are really different functions. Now, this example suggests that there's a real richness to this theory of functions, right? We're going to be studying it a lot more this term.